All right, welcome back. Last video of this unit or this lesson. So we're talking now about our trig ratios again, but this time we're talking about our special triangles. Okay, so we have learned 45, 45, 90 triangles are quite unique. When we labeled our triangle before, we said these two sides are legs, the sides that are across from your 45-degree angles, they're going to be exactly the same. We called them X earlier, but we're now, I'm going to erase out, that just looks messy. We're now just going to call them 1 because that's the easiest number I can multiply by. Okay, so we're going to call them each length 1, which means if we're following our special triangle, this side right here was just x squared to 2, or in this case, 1 square root of 2. Okay, so we've got now our 3 sides of that lovely triangle labeled. Let's go ahead and look at this triangle first. So if we choose, they want us to find the trigonometric ratios for all of these values. So they're going to start off with a 45-degree angle first. So we're going to call one of these 45-degree angles theta. Across from it, here's our opposite side, and then our hypotenuse is always going to be across from our right angle. That leaves this last side as our adjacent side. All right, again, I'm going to just write down to remind myself that SOHCAHTOA will help me to remember my ratios right here. So when I look right here at the sine of 45 degrees, my sine, again, is my opposite over my hypotenuse. So in my picture right here, my opposite was 1 over my hypotenuse is the square root of 2. Now remember, do not let that radical stay in the denominator. So we're going to multiply both the top and the bottom by that square root of 2, and you're going to end up with the 1 square root of 2, 1 times the square root of 2, over the square root of 4, which is just 2. So that's your ratio right there, that sine, that square root of 2 over 2. Now the cosine, look at how cool this is. The cosine of that 45-degree angle is the exact same value. The cosine right here is your adjacent over your hypotenuse. But notice my adjacent is also 1, just like the opposite is. So it's going to be 1 over my hypotenuse, which is square root of 2. We already simplified it over here, so I'm just going to go ahead and write that when you rationalize that denominator, you get the square root of 2 over 2. Okay, the last one is the easiest one right here. The tangent of theta, tangent of 45, was my opposite side, so this 1 right here, over the adjacent side. So I just have 1 divided by 1, which is just 1. Okay, same thing with the 30, 60, 90 triangle. I'm just going to call my x 1. So I go across from 30, that side is 1. Across from my 90 was 2x, so 2 times 1 is 2. This side over here is going to be the square root of 3. Okay, now we're going to need to label our triangle. First, we're going to label it with our theta being our 30-degree angle, because that's what they're asking for first. So we're going to call that theta right there. And we're going to label our triangle. So we're going to go across from it. Here's my opposite side. Across from my right angle, there's my hypotenuse. That leaves this last side as my adjacent. Okay, and then we can just go in and fill in our ratios. So my sine is my opposite over my hypotenuse. Opposite right here is 1, and my hypotenuse is 2. So 1 over 2, nice and simple. Cosine is my adjacent, so that's square root of 3 over the hypotenuse, which is 2. And then my tangent, the tangent up here is the opposite, which is 1, over the adjacent, which is the square root of 3. Radical in the denominator. Multiply both the top and the bottom by that square root of 3. So I have the square root of 3 over the square root of 9, which just turns into 3. And we have that value for you as well. All right, for our last one, we're going to use our smartboard to change our angle. They're asking this time for the 60-degree angle. So when we change our angle, it didn't change the hypotenuse, so this side gets to stay there. But this side is no longer the opposite. So we're going to move this one down over here, switch it out for the adjacent over there. So our values haven't changed, but the side names have changed. Okay, and then we do the same thing. Our sine is our opposite over the hypotenuse. So my opposite here now is the square root of 3 over 2 is still your hypotenuse. Okay, the cosine is your adjacent over your hypotenuse. So my adjacent was 1 over my hypotenuse was 2. And then our last one, our tangent, the opposite this time is the square root of 3. So we've got the square root of 3 on the top over the adjacent, which is 1. This is just the square root of 3. And you found the 3 trig ratios for all your angles in those special triangles. All right, thanks for tuning in. See you next lesson.